In this video, we'll be looking at different ways to set up target shapes. Target shapes are useful if you want more control over the shape of your muscle when it contracts than you get just by tweaking the parameters in the muscle properties alone. You can create the target shape either manually or procedurally, and then whenever the muscle is activated by the muscle flex, then the muscle will treat that target shape as a blend shape target in the solver. So let's have a look at this file. I've got 3 different methods. This isn't really exhaustive. The nice thing about this is it gives you a fair amount of flexibility, but I'll go through some different options. So firstly, I'm going to look at manually sculpting them in Houdini. You can, of course, also sculpt them in another program and import them, or get someone else to do that for you. It's up to you. If it's done externally, it would be done on the original mesh. And we can also sculpt on the original mesh directly in Houdini. So here's the original mesh. I'm going to just isolate one muscle. You don't have to just do one muscle at a time. You can do a couple. You can do as many as you want. That totally depends on you, and you can also merge them together later. But let's just look at one muscle for now. Spacebar F. And let's say I've sculpted it with a sculpt node. And let me hit enter to. Thing just went wrong. The viewport stayed there. Okay. So now we are looking at the sculpt. It's not very nice, but I purposefully made it a bit ugly because I wanted to show something. So now we have our target shape that we want, but this is on the surface mesh, and we actually need to transfer that target shape from the surface mesh to the tetrahedralized mesh that gets used for simming. To do that, I repeat, do not use a point deform. What we will use instead is an FEM deform, which in terms of inputs and outputs looks quite similar to a point deform, but it's going to be much better to maintain the shape of the tetrahedra inside, whereas a point deform can cause unwanted inversions, etc., on the internal tetrahedra. So here I have blasted the same muscle from the solidified sim mesh. So there it is there. Again, if you have multiple muscles that you've sculpted simultaneously, you just blast all of the ones that are relevant. And then the FEM deform will take the solid muscle or muscles as the first input, the deformed or sculpted surface muscles as the second input, and then the rest surface muscles as the third input. So much like surface deform or point deform, the point order of the second 2 inputs must match, and the shape of the first and third input must match. So now we get this, which is not fully matching the shape. So this is actually running a quasi-static simulation in order to maintain the tetrahedra shapes and try and match it as closely as possible based on the settings here. I've already increased this value quite a bit higher than the default. The default is 1E7. I find I need to get it a bit higher to get it to match properly, and then I'm going to reduce the stiffness multiplier, and that's a pretty good match. But now when you do this, when you increase that attached strength and or decrease the stiffness multiplier, you're more likely to get inversions. So let's test that by looking at the visualize quality. I check that on. I set the type to inversion. By default, it's set to mesh quality. So set it to inversion. Now what you're going to see in this is it's going to show the exterior surface in wireframe, so the second input, and then any inversions it will show in red, okay? And that's an inversion in the result of the deformed first mesh, first input. So here we see there's an inversion, and I kind of sculpted the mesh here to be a bit weird on purpose in order to create that inversion. If you increase this and decrease this, the inversion will disappear, but then you'll go back to, if I turn this off, you'll see the result. You'll have the mesh follow less accurately. So it helps to try and avoid funny angles like this on your target sculpted shape to begin with. But just bear in mind that you want to check for inversions. But if you're not seeing anything except the surface, then that means it's fine. So now we can see the result. Let's just go back to, I'm sorry, it was actually lower, not higher. And I'm going to redo the sculpt because I don't want it to be ugly. I'm going to say reset. And let's say what we actually want. I quite like using the inflate brush for this because inflating is more or less what a muscle does when it bulges. And you can, I'm holding down shift to go to smooth. I like to set the smooth strength really low, otherwise it just sort of smooths away anything you've sculpted and then some. Okay, so I'm not going to try to do the best sculpting work here. It's just for demonstration purposes. But you might, typically you'll want to increase the volume sort of in the belly of the muscle and then maybe decrease it a bit in the, towards the ends. Now maybe the smooth is a bit too, and we can also move it. I'm really not doing an amazing sculpt job here, but you get the idea. So now there we have the result. So one thing to notice here is the resolution of this solid muscle is limiting the shape a little bit. We can't really get this volume filling in nicely because there aren't points there. So this is a case where you might want to, either you'll say, okay, that's fine. B, maybe you'll sculpt a bit in other ways to try and make up for it. Or C, you might want to change the resolution of your solidified mesh. And if you're going to be changing the resolution of the solidified mesh, this is a convenient example to indicate why it helps to sculpt on the original mesh instead of the remeshed mesh, because that might change if you're still tweaking with it. So in this case, we use the original mesh. Let me just show the rest of the workflow. So we've got let's refresh it. So we've got our tetrahedrons in the shape that we want. Now we need to save this shape. So these are the two most important steps. We want to save this shape as an attribute called target shape on the original, by original I mean the original sim solidified mesh. So basically we will use a rest position node and in the store mode set target shape. Now, in case you're worried that you're going to struggle to remember all of this, there is a very handy recipe. If you go under character effects, muscles, and then muscle target shape, and you drop that down, it's going to create a network of nodes with the two most important things you need, the FEM deform and the rest position node with the attribute set to target shape, as well as nulls that just label the inputs clearly. So you want your solid muscle in the first input, that's the sim mesh. You want your deformed one as the second one, and the rest mesh as the third. Again, these two must match in topology. These two must more or less match in shape. Okay, so that's where I got these nodes from. So you can use that very easily. But now the final thing is, as you might have realized, we've copied the target shape onto this muscle, but now we only have one muscle and we actually want to sim all of the muscles. So if you watched the video on the de-intersection video, I went through how you can use the enumerate node and attribute copy for if you're splitting things. So I've added here for this setup, and I've highlighted in yellow, an enumerate node where I saved the attribute as index. I'm not going to go through this whole thing again. Watch the other video too if you're not following. But basically, this is the stream with the full muscles over here. And this is the split muscle. And then I just use an attribute copy with the attribute to match set to index and the attribute name set to target shape to copy the target shape to all the other meshes. Now, The one other thing that's important if you use this is that you still want target shape attribute saved for all the muscles that you didn't specify one for. Otherwise, it will be set to 0. And then whenever they are activated, they're going to try and go down to nothing. So you need to initialize the target shape on your other muscles just with their current position. So basically exactly the same node as this, but with no second input. On your rest muscles, you just create a rest position node with target shape. Okay, so then this, when you're here, it's going to override that target shape value for this muscle that's specified there, and we'll keep the target shape for the, just as their rest for all the others. So this is very important to remember. Okay, so now let's look at our other options. Oh, I was in this option already. Well, okay. This part is all basically the same though. What I did differently here is instead of sculpting on my original mesh, here I sculpted on the surface of the solidified mesh. So we still can only sculpt on polygonal surfaces. So if we want to sculpt this on this, we need to convert it back into polygons. So to do that, we use a convert tats node. So now here you can see tetrahedrons and here polygons, right? So we use this to get it into a mode that we can sculpt on. And then we'll just use the same converted tats unsculpted as our rest. Okay, and this is completely valid too. Just remember that if you go and you fiddle with your settings for your muscle solidify, or if you have a remesh before your muscle solidify, or even if you have a model update and something changes, it can cause changes in the point count and you'll have to redo a sculpt. Okay, so this is completely valid. It's just a little bit more prone to you losing your work. So only do this if you're just doing something very rough maybe and you don't mind risking redoing it. But if you're going to be spending a long time sculpting special shapes, I would strongly recommend doing it on the original mesh instead. Okay, now these are for manual options, but now let's take a look at some procedural options we have. Okay, so in this case, I have a little subnetwork. This is, let's dive inside. So this already has a convert tats node. So in this case, we're doing it on the solidified mesh that we've converted instead of the original mesh. It's not that you can't do anything procedural on the original mesh, but in this specific case, we are using the tendon mask attribute, and that exists on the solidified sim mesh. So it's just a bit simpler in this case to use it this way. So we've got our convert tats to convert it to polygons. Then this is something to measure the thickness. I'm not going to go through all of this. It's just copying the thickness. But basically the bulging is going to be based on the thickness and the tendon mask. And then you can, this is sort of various things, but what you can then do is, and this is doing it on all the muscles. So we haven't isolated any muscles. You can totally isolate it on specific muscles if you wanted to, but you can then tweak the factor and how strongly you want the tendon masks to bulge to get the shape you want. What I've also added here is use fiber volume scale, which what you can do is in your muscle properties node, what I've done is for some of my muscles, I've set a pretty big fiber volume scale, much bigger than I'd use for a sim. I'm actually going to reset it later on, but I'm just using this here, a little workaround hack so that I can set different values for different muscles using this interface. Because otherwise you'd have to have something like a attribute adjust float and you'd have to have a new one for each muscle. So I thought this is, why not just make use of this existing interface where you can set the relative scales of the muscles. So this one I've set to 3. The general fiber volume scale is 1.3. So that when I use the fiber volume scale, I think I used it specifically on I mean, I used it on all of them, but that one with the 3 is largely for this glute, right? So that's just going to help you get a bit more control over the bulge for individual muscles. I'll talk about the reverse in a minute. But yes, so in this case, because I'm using the target shape, I'm not worried about the fiber volume scale too. So that is why I'm using sort of unrealistic fiber volume scale values here. And then what I've added here is an attribute adjust float to set the fiber volume scale attribute back to 1. Okay. So before here, it was set to values by this. And in this case, I'm resetting it to 1. And in the other stream, I'm just using those fiber volume scale values to set the target shape. So that's just a little thing to be aware of what I did here. If you find that confusing, you can uncheck use fiber volume scale and remove this and just use the fiber volume scale as you normally would. Then what you can do is you can still make some sculpt adjustments if you're not totally happy with just the procedural stuff. So here I still wanted just a bit more bulge in the bum. So I just did a quick sculpt, but again, remember when you're using the convert tets on the solidified mesh, if there's any point count change, you're going to lose your sculpt here. So only do it for small tweaks that you are prepared to redo if necessary. You can also use a combination of the procedural bulging and the sculpt method, especially if you want to sort of start with the procedural. You would do the procedural bulging first and then specify a sculpt on any ones after that that you want to override. But in any case, you're creating the shapes procedurally, but they're input into the FEM deform exactly the same way. Again, remember to check for inversions. You might want to tweak stiffness multiplier and attach strength. Still checking for inversions. That looks pretty good. You can wireframe your deformed surface to see that it lines up nicely. It looks like it's matched it pretty well. And then here we're going to just use this rest position to copy the target shape to the muscles. And in this case, because I did it on all the muscles, I don't need to do the whole attribute copy with the enumerated attribute. This isn't limited to being used in a procedural way, but it was the easiest to show procedurally. So if you look at the character in the T-pose, something like this, usually when you're standing, a lot of your muscles are already either contracted or partially contracted, right? You don't have all your muscles completely relaxed when you're standing. So if you find that you actually want to have a so-called target shape, it's not going to be called target shape, but the concept of a target shape for when a muscle is relaxed, what you're actually going to do is you're going to edit the rest instead, right? Because you want to say, okay, this is what it looks like when it is at rest, or what we call the rest attribute in the muscle system is T-pose. Okay, so this is maybe almost a contradiction, but so we're basically going to set our T-pose position to be what we want it to look like when it's fully relaxed. So what we can do to create those procedurally, I just did it here on a subset of muscles too. I basically used the same procedural setup as this, but I didn't use the fiber volume scale, and I toggled on reverse bulge direction so that it bulges inwards, i.e. it reduces in size. Okay. I didn't want to go too far because it's mainly just that we wanted a bit more relaxed. Okay. But then everything else is exactly the same in terms of FEM deform to deform it. Right. And then now the big difference here is instead of saving it to target shape, we are going to save it to T-pose. That's the only difference. So we save it to T-pose. And now because we've only done it on a subset of the muscles, we need to copy the new T-pose values using the index to match with the enumerate specifying there. And in this case, we already have a T-pose attribute initialized before from the muscle solidify, so we don't need to initialize it first the way we did here with the target shape before the attribute copy. here, that's the way in which we've used a combination of changing the muscle and then telling it to update the T-pose based on that, and then changing the muscle, telling it to update the target shape for when it's flexing based on that. And then just to give a little bit of a reminder, if you're in the case where you want your muscle to, in the T-pose, to be semi-flexed so that it's not going to activate or kind of start off in the T-pose attribute, what you can do is adjust your rest length with an attribute adjust float on your tension lines so that they can start off flexed in their T-pose position, but then later they can go into a more relaxed position, and then it will be unblended from the shape into the rest position shape. But that means that it's kind of lost the data of whatever it was at T-pose originally. Once you update that T-pose data, that shape information is lost. But you could also, perhaps you only wanted to specify T-pose, you could use whatever you had before. You can save it as a target shape, right? Basically the same way that you just initialize the target shape here as whatever you have currently, initialize that as target shape. You could do that so that you save your previous T-pose before you update it to the relaxed one as a target shape instead. So maybe for some muscles, you'll do that. For some muscles, you'll specify a bulge target shape. For some muscles, you might want a relaxed T-pose, and for some muscles, you'll use your original T-pose. So the thing with this is there's a lot of flexibility, which can be a little bit confusing. It's really not limited to just what I did here. You can get very creative with how you want to do it. If you want, you can merge a whole bunch of these together. If that's strange, you can merge a bunch of different sculpts together, but just make sure that you have the same muscle specified in all your others with the same point order. The reason I put it in this part of the network is because the procedural method that we've used uses the tendon mask. I mean, you could come up with a different procedural method too. It doesn't have to be this specific procedural method. But because we use the tendon mask, we put it down after the muscle properties and the muscle paint and all of that. But if you're not doing it procedurally, you can, and you're just sculpting it, you can specify these T poses anywhere after your muscle solidify, as long as it's before, I would say, your muscle flex, because that's when it starts becoming time dependent. So you want to do it before any time dependency comes in. As a side note, you can also have your target shape changing over time. I'm not going to cover that because it's a bit more complex, but it should still work if you're interested in that. But yes, you could, let's say we wanted to sculpt right after the target shape, right after muscle solidify. We can place it here, but we'd want to sculpt it on the original mesh. So let's say maybe you can either do this with blasts or splits or something, but let's say, let me press 9 for group. But let's say we want to do this one here, delete non-selected, and this, and then maybe this, and then I'm going to sculpt. Okay, before I do that, I need to just show you something that you'd have to have. So the muscle solidify is going to set your T-pose for you, but I'm going to show something that uses a T-pose on the original mesh too. So I'm just going to put in, even just going to copy this and put it in there. So now I've got my T-pose on the original mesh already. And I'll show you how that's useful in a minute. So now let's say I'm going to sculpt this, and then, whoops, going to reset, sculpt that, and reset and sculpt that. And now I'm going to merge them all together. Now, if I do the target shape, these two need to match, right? And instead of having a million wires everywhere and blah, 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 especially imagine you have a lot more of these, what I can do here is these are all my sculpts merged together. If I now have an extract T-pose, then this can be my first input. Sorry, my second input, and this is my third input. And now we just need to make sure that for our solidified muscles, we blast the same ones as before. So that will be this one, and this one. Delete unselected. Set this higher so that we get a better match. Okay, it's still not perfect match, but I think it's pretty good. I mean, I did a bad sculpt there anyway. And then again, we would just, oh, this is missing the enumerate. Okay, you would just want this enumerate to be up there. I don't want this file to get too confusing. But you would essentially, whoops. Or maybe for simplicity, I will just connect it there. Maybe I can put this at the end after the others. Okay. So now we've copied the target shape onto this. Now the only problem is I haven't initialized the target shape. I just realized. Okay, so now if we want to double check that this all looks good, firstly, let me just move it, delete those. And I'll move these across to there. Okay, I'll tidy it up before I share the file. But now let's say we just want to double check that the target shape has been applied correctly. If we go to extract T-pose, and instead of this, we just set this to and now we can see that looks great. And if I forget to initialize the target shape, oh, it actually initialized it fine. Maybe it's just remembering it. Sometimes it stores things. I still would just put it in to be safe. But that is how you can just confirm. Okay, so those should hopefully give a pretty good overview. So in conclusion, the most important two nodes are the FEM deform and to transform the sculpted shape onto the solid muscle, and the target shape storing using this rest position node. Other things to just remember is to sculpt on polygonal mesh, not tetrahedralized mesh, and to use enumerate and attribute copy with index or whatever attribute you call it, attribute to match specified if you're splitting it. Great. I hope that will be useful